M6C3 test electromagnetism. Question number 10. This is actually quite a tricky question. A coil, this is in reference to this particular diagram here. So a coil of 50 turns has a cross-sectional area of 4.2 times 10 to the minus 3 meters squared. So no funny business so far. It is placed at an angle to the uniform magnetic field of flux density. So flux density 2.8 times 10 to the minus 2 Tesla. No funny business there. As shown in the diagram, so that angle theta is 50 degrees. What is the change in flux when the coil is rotated anti-clockwise until the angle is 0? So this question is asking us to subtract two flux linkages. We want the flux linkage from its current position in the diagram, and then it's going to rotate anti-clockwise until that angle becomes 90 degrees. No, wait, until that angle becomes 0. So rotate anti-clockwise until that angle becomes 0, and then we're going to subtract those two magnetic flux linkages. So first of all, I'd like to work out the magnetic flux linkage as it sits in this picture. So for that, I'm going to have to consider whether I need a sine or a cos. So if I were to rotate this coil this way, the angle would be 0 and I want a maximum. If I rotate it this way, the angle would be 90 degrees and I want nothing at all. So I'll be choosing a cos to be dealing with this angle here. So effectively, I'll put my change in flux linkage n phi would likely be n phi 1, sorry, n phi 1 subtract n phi 2 effectively. So it's like a before and after type situation. So the before is going to have to be NBA, and we've chosen cos because we've looked at the diagram, cos of the angle, and then I'm going to subtract from that the flux linkage when that angle is 0, and when that angle is 0, I'll end up with a maximum flux linkage, so that's just going to be NBA. Right. So that's going to be NBA cos theta, the initial flux linkage, subtract NBA, the final flux linkage. You could include cos of 0 if you like, but cos of 0 is just 1. So the change in flux linkage between those two stories is going to be 50 turns times magnetic flux density 2.8 times 10 to the minus 2 times the cross-sectional area, which is 4.2 times 10 to the minus 3 times cos of 50 degrees. Make sure your calculator is set to degrees and not radians. All of that, and I'm going to subtract from that NBA without any funny business on the end. So that's going to be 50 times 2.8 times 10 to the minus 2 times 4.2 times 10 to the minus 3, and then that should give you the correct answer.